Before we set sail, it's important that we carry out a few basic checks of the engine. The things that we're going to be looking at are the fluid levels, the belt tension, and the basic condition of the engine. Let's start by checking the oil. To check the oil, we're going to need a rag. First, withdraw the dipstick and rub off the dirty oil. Locate the maximum and minimal marks. Dipstick back into the tube. Withdraw once again and note the oil level. And you can see here that the oil is just below the maximum level. It's important that we don't overtop the oil. The oil shouldn't be much above the maximum level. The next thing we're going to check is the gearbox oil level. First, locate the dipstick on the top. In some boats, you may need a spanner to undo this. Unscrew it. And wipe the dipstick clear. Then place back into the hole, but don't screw it down, and withdraw it. As you can see, the oil level here is just above minimal level. The next thing we need to check is the condition of the oil. The oil should be clean and clear and should not be milky or black. If it's milky, it shows that we've got water ingress into the gearbox. Or if it's black, it shows signs that it's been overheating. If your engine is a freshwater cooled engine, the next thing we need to check is the freshwater level. This engine is fitted with a remote header tank. You can see the water level through the side of the header tank. It sits between the minimum and the maximum level. If you don't have a remote header tank, then remove the cap off of the heat exchanger and look inside. The level should be about an inch below the lip. The next thing to check is that the seacock is actually open. If it's closed, open it up. The next thing we're going to check is the fuel shutoff valve. These are normally located in lockers and we must check them. We must check that they're fully open. If they're partially closed, then the engine will die. This one's fine. The next thing I'm going to check is the bilges. We like to keep the bilges as clean as possible. This makes it easy to detect any leaks. As you can see here, we've got a small oil leak that's developing. We need to mop this up and then keep an eye on it. So now we've cleaned the bilge, it'll be easier for us to monitor the leak to see if it gets any worse. And hopefully we'll be able to find out where it's coming from. On this boat, we've got fitted a filter with a metal bowl underneath. And what we need to do to check the state of the fuel is to take a sample. What I've done is cut the top off a lemonade bottle. I'm going to place it underneath and get a sample of the fuel. Undo the drain plug. Allow a sample of fuel to fill the container. Doesn't need to be much. Nip it up. Let's have a look at the state of the fuel. As you can see, it is very, very clear. There's no trace of dirt and there's no trace of water. If there is any traces of water in there, then we have to drain this more often and keep an eye on it. In this section, we're going to demonstrate changing the fuel pre-filter. We're going to show you two different types. The first one being the CAV type. So the first thing we're going to do is put loads of rags underneath to catch the drips. Next thing, I've got a container that I've cut off, which I'm going to place underneath. Then we need an 11mm socket or spanner and undo the centre bolt. Once the bolt's free, ease the filter off and catch the parts like so. Have a quick look at the filter. As we can see, there are signs, a bit of a sign of a small amount of muck in there, but nothing to worry about. So now we're just going to reassemble with the clean filter. Okay, so first clean the bowl, dry it out, like so. And we're going to replace the seal in the lower bowl because normally they stretch, so we're going to put a new one in, and then the seal should come with the filter. There's two seals that come with. One is slightly larger than the other. The larger one goes into the upper filter housing. Place the seal on like so. Little film of fuel around it. Place the canister on top, like so. We're not going to change the seal in the top of the filter this time. We're just going to make sure that it's in place, and we're just going to stick our fingernail up, make sure that we can feel it. The two components together like that and the seal in place, hold it underneath, lift the centre bolt up, push up, and then locate the bolt. Nip it up, and then just run your finger around the ledge just to make sure that the seals haven't popped out. We're now going to bleed this engine. So if we follow the fuel line from the pre-filter, we find the lift pump, and this is the priming lever. Then we go on to the fine fuel filter, and on the top of there's a bleed screw. Crack off the bleed screw, which on this engine is a 19mm spanner. Undo it a couple of turns, and then start priming the pump. Keep pumping until you get good clean fuel coming through. Once you've got good fuel coming through, we nip it back up and tighten it up. A common cause of breakdown at sea is the failure of the drive belt. It's important that we check this before we go out to sea. So to check the belt, we put our finger between the two pulleys and depress the belt with a moderate amount of force. It should go down about ½ an inch and it should feel tight. We can see on this engine that at some point this belt has been slipping. There's traces of fine black dust here, which means that the belt has been wearing. So whilst doing some checks on this boat, I've noticed that when I've pushed down the belt, the alternator is moving and is loose. This is something that we must tighten up. The belt has already started to slip because you can see the fine black dust. We've now carried out the majority of our checks, but before I close the engine bay up, I'm going to have a good look round and check that everything is safe and secure. We've now carried out all the engine pre-start checks, but before we start the engine, there's one thing we haven't thought about, and that is the fuel. We must ensure that we have more than enough fuel for the journey that we're about to undertake. I like to carry at least twice the amount of fuel that I require for the passage. This allows me to deal with any unforeseen circumstances, and I very rarely run my tanks below half. I like to keep them between a half and full. We're now about to start the engine, but before we do, what we need to do is check over the stern and make sure there's no stray lines lying around. That's all clear. Okay, switch the panel on. This panel has an alarm test facility. Check that the alarm works. Apply about 15 seconds of heat. Press start. Once the engine's running, check that all the warning lights are extinguished. Check over the side and make sure you've got a good flow of water coming from the exhausts. So now we're ready to go. We've just carried out the pre-start checks on a yacht fitted with a sail drive. The pre-start checks apply to most types of boat, but there are a few additional things that we need to look at on a powerboat. We're now on a Jeanneau Mary Fisher, fitted with a Volvo TMD 31P. This boat is shaft driven, so let's have a look. With a shaft driven boat, it's important that we check that the shaft is clear, that nothing has fallen down on it and nothing is obstructing it. The shaft will rotate at up to about 3000 RPM, and if anything gets wrapped around it, it could be catastrophic. Everything looks okay down here, but the shaft continues into the aft locker. So let's have a look in the aft locker and make sure everything's all right. We can just see under here the stern gland, and it looks fine, it's not leaking. We've got a nice cover over the top of the stern gland. However, what we've got here is a potential disaster. We've got fishing lines here which could fall in and go around the shaft. Now if the fishing line goes around the shaft and the hooks follow it, then it could damage the stern gland and we could have a serious leak. So the best thing we can do here is to move it all out the way and make sure that it's tied up and secured. I'm going to take a sample of the fuel to see if there's any water or dirt in it. Place some rags underneath. Then put your container underneath the bowl and open the drain cock and take a sample of the fuel. Nip the drain cock back up, remove the container and check it. As you can see, this is lovely and clear, there's no sign of dirt and no sign of water. I'm now going to show you how to change the filter element. First thing we need to do is shut off the fuel. This boat is fitted with a Raycor or CPAR type filter. They come in various sizes and this is one of the smaller ones, but the same principle to change the element applies across the range. We're now going to change the filter element. So undo the T-bar on the top. And remove. Take the lid off carefully. You'll note that there's a seal on the inside. Next, have your bucket ready and very slowly lift out the element. Allow the fuel to drain into the bowl. Now we want to have a look at this filter to see if there's any signs of diesel bug or dirt. Just prise the vanes open like that and look inside. This one looks fine. There's no sign of dirt or diesel bug. Now if we found dirt or muck in the filter, we'd want to drain all this diesel out before we put back the new filter. So with the lid off, place a container of suitable size to take the amount of fuel. Open the drain cock again. Once all the fuel is out, we're now ready to refit the new and clean element. Normally fitted with a handle on the top. Place it in over the spindle, like so. Make sure the drain cock underneath is shut. To minimise the amount of bleeding that we have to do, we're now going to fill up the filter from a separate diesel can. It's always worth carrying a small can of diesel just in case you need to do this. We're now about to put the lid back on, but before we do, we're going to change the seal. Just tap the plate like so. The new one, the filter should come with a new set of seals. Before we put it in, we just want to put a bit of clean diesel around the seal like so. Then place it into the top of the filter. And then carefully place it back on like so. So before we put the T-bar back on, we're just going to remove this little O-ring and replace it with the new one that's come with the filter. Again, cover it with a bit of clean diesel and gently ease it over the threads. Like so. Place the T-bar back into the top and tighten. Okay, that's the filter now changed. We may have got some air into some of the pipework, so we're just going to bleed the first fine filter on the engine, just to make sure that there's no air got into the system. Once we've finished changing the fuel filter, of course it's very important to remember to open the fuel valve. Now we're ready to bleed the fine filter on the engine. I'm now going to show you how to bleed this engine. With the first engine that we bled, we had to bleed up to the fine filter, and that was all we had to do. With this, it's slightly different. We bleed up to the fine filter first, but then also we have to bleed the injectors. So first of all, we need to locate the fuel lift pump and the fine filter. Now on this boat, unfortunately, it's not terribly easy to see. The fine filter and the fuel lift pump are situated just down here. Crack off the bleed screw on the top of the fine filter. About a couple of turns will do. If you can get a rag or a container under it, then do so. Then we need to pump the lift pump. So pump the lift pump until all the air disappears and you've got clean, pure diesel coming through. Then nip up the bleed screw. We've now bled the air out of the fine filter. The next step on this engine is to go straight to the injectors. So what we need to do is, with a 17mm spanner, is crack off the injector nuts. Now we do all of them. So this is a 4-cylinder engine, so we're going to crack off all 4. Just need to be loosened a couple of turns. Give the pipes a little gentle pull up like so. We're now working on the high pressure side of the fuel. So in order to bleed the air out of this system, we need to turn the engine over on the key. This part of the engine bleeding requires 2 people really. One to be by the engine to look at the injectors, and the other to turn the key over. When you bleed the injectors, it's best to push the button in and put the throttle into neutral but full ahead. This opens up the fuel pump and allows the air to come out quicker. Then turn the engine over. And at the injector, if it's got air in the system, you should see bubbles at first, and then you should get a good healthy squirt, about 6 inches in height. Okay, we've carried out all our pre-start checks, but one additional thing that you have to bear in mind with a powerboat is that they're normally fitted with an in-gear protection. So before you start the engine, make sure that it's in neutral. We're now on a Mum 36 with a Yanmar 2GM engine, and I'm going to go through the process of bleeding the engine. The difference with this is that it's important that after we've bled the pre-filter that we do the injection pump. To bleed the engine, first we need to find the lift pump. The manual lever for priming is just underneath, and from there the fuel is delivered to the fuel filter, on top of which is a bleed screw. If If we undo the bleed screw, you can see the vent hole in the side of the vent screw. Place a rag around to catch any excess fuel, and then manually pump the lift pump. Make sure that you get rid of all the air bubbles. You should get a good clean spurt of fuel coming out. Once you're happy with that, lift up the vent screw and clear up the fuel. The next thing we have to do is to vent the fuel injection pump. This engine, if it has air in the fuel injection pump, will not start. The fuel injection pump is situated under here. If you have trouble finding it, follow the injection pipes back from the injectors and you'll see where they go into the block. You need a 10mm spanner for this. Crack it off, undo it a couple of turns, and once again pump the lift pump until you get no air coming out, just clean fuel. Nip it up. And the engine's ready to start. With this particular engine, there's no need to bleed the injectors. Now, if we were carrying out the pre-start checks on this engine, you'll notice that this header tank, in order to check the fresh water level, you would need to take off the cap. Now, you mustn't do this when the engine is hot because this will be pressurized. So only do this when the engine is cold. Take the lid off and just check the level inside. Normally it should be about an inch, half an inch to an inch below. Replace the cap. If you do fill it up, don't worry about overfilling it. The cap has a pressure release mechanism, and as the water expands, it will lift and discharge the water and find its own correct level. The first scenario we're going to look at is no power to the panel. The most natural thing to check will be the battery isolating switch. On this boat, the battery isolating switch is underneath the chart table. And what we're going to do is just turn it off and turn it back on to make sure that it is on. It's very easy to get confused, especially if you're out sailing or somebody knocks it. So just double check. On some boats, you'll have fitted also a separate earth isolating switch, so just double check that that's on as well. This boat has a very typical battery arrangement. We have two domestics that are linked together and one separate dedicated engine start battery. What we're going to do now is just check that all the battery terminals are tight and secure. We now need to check the battery voltage. If your boat's fitted with voltmeters, we just need to check on the panel to see what voltage we have. If not, we're going to have to use a multimeter. A multimeter looks very complicated, but all we're actually interested on here is the range up to 20 volts. As we saw from the multimeter, the battery is fully charged. If the battery voltage drops below around 6 volts, there won't be enough power in order to initiate the lights on the panel onto the engine. We need to check the main battery positively to the starter motor to make sure it's connected. Pull the cable to make sure it's not come out of its crimp. The next thing is the earth cable. This is normally bolted on at the back of the engine, directly to the engine. Again, wiggle it around, make sure it's tight, not corroded. Some engines, not all, are fitted with control fuses or semi-automatic breakers. On this Volvo, we have a control fuse. Power comes into the top and there are 4 different outlets underneath. We can move the wire along to the next fuse. Now if that works, great, but if it blows again, we do have an electrical short and we need to call in an electrician. Finally, the last thing we're going to check is the main wiring harness that comes from the panel is secure on the engine. Make sure that it's tight and well secured. Hopefully, sometime through that process, we will have found the problem. If not, we've narrowed down some of our options, and now it's probably time to call for assistance. The next scenario we're going to look at is that we've got power to the panel, but the engine won't turn over. If you're a powerboat, the first thing you must check is that the throttle control lever is in neutral. The next thing we need to check is that we've got battery voltage. Now before we go any further, let's try and see how a starter motor works. So this is a typical starter motor that we find on most boats. And what we've got here is this is the actual motor part. This is the Bendix and this is the solenoid. Now the solenoid is really just a big switch. When the solenoid is activated, it activates the lever which engages the Bendix and then makes a contact between these 2 bolts here and allows power to travel to the motor. What I'm going to show you first is what happens to the solenoid when we turn the key. Apply my earth lead, that's the simulated earth lead that we'd have on the engine. When we turn the key, as you can see, the Bendix has gone and will be engaging into the flywheel. As that happens, this piston has gone forward and makes a contact between these 2 large bolts at the end, and this is where our battery lead will come into. So if we now put the battery lead onto there, and apply power, that's what happens when you turn your key. This boat has a very typical battery arrangement. We have 2 domestics that are linked together and 1 separate dedicated engine start battery. What we're going to do now is just check that all the battery terminals are tight and secure. We now need to check the battery voltage. If your boat's fitted with voltmeters, we just need to check on the panel to see what voltage we have. If not, we're going to have to use a multimeter. A multimeter looks very complicated, but all we're actually interested on here is the range up to 20 volts. As we saw from the multimeter, the battery is fully charged. If the battery voltage drops below around 6 volts, there won't be enough power in order to initiate the lights on the panel onto the engine. We need to check the main battery positive lead to the starter motor to make sure it's connected. Pull the cable to make sure it's not come out of its crimp. The next thing is the earth cable. This is normally bolted on at the back of the engine, directly to the engine. Again, wiggle it around, make sure it's tight, not corroded. Okay, we're now back at the engine. If when we turn the key switch we're getting a large clunk or click from the starter motor, we're pretty sure that the ignition circuit is working okay. And what we might need to do is give the solenoid a gentle tap with a hammer. Now we do this with somebody upstairs activating the key switch on and off and somebody down here gently tapping the side. It might be that the solenoid is just simply stuck, and a gentle tap may free it up. This is the solenoid on this engine, and we would tap it just here. Obviously be careful not to hit the live terminals, and it would just be a gentle tap against the side. If the engine is under warranty, this is probably not such a good idea. If there isn't any clicking at the starter motor, the next thing I'm going to do is measure the voltage from the key switch at the starter motor. And in order to do this, I'm going to use the multimeter again. Connect the black lead to earth, which is anywhere on the engine. Then remove the wire from the starter motor. Gently put in the probe, or hold the probe in. Now get somebody to activate the key switch. And when you do that, we should be getting a good strong voltage on the multimeter. If when we press the start button, we're getting a good voltage down at the starter motor as we showed there, then the problem is likely to be the starter motor itself. There is one other way that we can check to see if it is the starter motor or the ignition circuit itself, and that is by shorting out the starter motor directly from the battery lead, the main battery lead, to the terminal where it comes in from the key switch. And we can do that either with a piece of wire or with a screwdriver. Now, I don't advise this, but if it was an absolute emergency and as a last resort, we could try this. In order to do this, we want to put the ignition to on, and then with a screwdriver short across the terminals. Another scenario that you may come across is that when you go to start the engine, you get a loud, rapid clicking noise from the starter motor. The most obvious thing for this is slightly flat batteries. What's happening is the solenoid is going in. There's enough power from the batteries to put the solenoid in, but as soon as it tries to turn the engine over, there's a voltage drop and the solenoid comes back. And as soon as it comes back, enough power again to put it in. So it's rapidly firing the solenoid in and out of the flywheel. Another cause for this could also be a poor connection. So again, we're going to be checking the battery leads, the leads on the starter motor, and the main earth lead. And also, if you can get to the back of the battery switch, check the leads on the back of the battery switch. If it's a case of just a flat battery, then all we need to do is put the short side battery charger on for an hour, and that will probably top the batteries up enough to get the engine to start. Alternatively, if you don't have a short side battery charger, you're going to be looking to get a jump start. If the engine turns over but won't fire, the first thing we're going to check is that the engine stop is fully reset. The engine stop only has to be pulled out a slight amount to stop the engine from injecting. If your engine is in direct injection, you are dependent on the glow plugs for the engine to start, especially in cold weather. If one or more of those are failing, then the engine will either take a long time to start or won't start at all. Another more serious cause of the engine turning over but not starting is the loss of compression. Now this can either be a gradual thing, which you'd probably start to notice more in the winter months. Now one way of telling this is when you're turning the engine over, open up the oil filler cap. When you turn the engine over, you'll get a puff of vapour coming out of here as the engine turns over. And that is indicating that you're losing compression. This can also happen suddenly by a major failure, i.e. a breakage of one of the rings or a valve. Finally, we could try bleeding the engine and checking to see if there's any air in the filters. And if that doesn't work, then I think it's time to call an engineer. In this section, we're going to be looking at the saltwater cooling system and what actions you should take should your engine overheat. We're on board a 36-foot yacht with a Volvo Penta 2030 diesel engine connected to a cell drive unit. Okay. The cooling system on this engine is an indirect system. It has a pressurized freshwater system which is cooled by the salt water via a heat exchanger. First of all, we will go through the main cooling components on the engine. The water is drawn up through the inlet holes in the cell drive to the seacock. From the seacock, the water then goes to the strainer, where the weed and debris is filtered out. Then, from the strainer, the water then passes under the engine in this case, to the salt water pump at the front. The next component is the anti-siphon valve. And then from the anti-siphon valve, the water then goes into the heat exchanger where it removes the heat from the freshwater system. The final job of the salt water is to cool the exhaust gases. The cooling water is injected into the exhaust elbow and the combustion gases then force the water out along the exhaust and over the side. When you're ready to investigate, open the engine bay, but exercise caution. When the engine overheats, the freshwater system expands and overpressurizes, which can lift the safety valve in the filler cap, discharging boiling hot water into the bilge. For this reason, do not attempt to open the filler cap. Once you've opened the engine compartment, have a good visual check around. See if there's any obvious water leaks. If there's no obvious water leaks, we need to start and look at the salt water system. And the best place to start is at the seacock. First check that the seacock is fully opened. We're now going to check the strainer. So undo the lid, remove the top, and then withdraw the basket. Check the basket and ensure that it's not blocked. If it is, clean it out under a cold tap. Then replace it. Take care replacing it. It is important that these two edges slide into the grooves inside. Make sure that it's down firm. Then the cap, and then screw the lid back on. Tighten it up with one hand and then a little nip with two hands, like so. Now I'm going to prove that the saltwater system is clear from the inlet side of the strainer down to the bottom of the cell drive unit. Now to do this, I'm going to take off the pipe on the inlet side of the strainer. Now we're going to open the seacock and blow. We should be able to hear the bubbles coming out underneath the boat. Now if you don't fancy blowing, like so, you can use a dinghy pump by fitting it into the end and gently pushing down on the pump. Once you've done that, we know that the system is clear, and now we're going to put this back on. The next thing we're going to check is the impeller. If an impeller runs dry, it's not long before it can disintegrate or break up. Now to do this, we've got the seacock shut and we're going to start undoing the screws at the front, just here. And when you do this, make sure you've got a good quality screwdriver and the right size. So what we're going to do is just loosen off all the screws on the impeller housing like so. When you take the faceplate off, try and put your hand underneath to catch any bits that may come out. Try and save the gasket. Don't worry if you don't. You can always use instant gasket if you don't have a spare. Okay, this impeller looks pretty good, but just to be on the safe side, we should remove it. I'm going to remove it by using two screwdrivers on opposite sides and easing it out gently. We must take care not to damage the face, the bronze face around the outside. Ease it out like so. Now once it's out, we need to check it. Check at the base of the blades. Ah, look, and as you can see, this one is already cracked and started to break up. So this needs to be replaced. Now, if when we opened up the faceplate of the impeller looks something like this with all the blades missing, we need to find them all because they will be obstructing the cooling system. Now, obviously, some of the blades will carry on up here through the siphon valve and end up at the heat exchanger. But an awful lot of them will go back down the suction pipe here. So we would need to remove this suction pipe, flush the line through with some water and wash it all out and try and catch as many of the blades as possible. Once we've done that, we then can concentrate on putting the new impeller in. Before we put the new gasket on, we must remove all of the old gaskets. Just gently peel it off like so. We're now going to put in the new impeller. First, cover it with a bit of washing up liquid to give it some lubrication. Now, this impeller has a grub screw going through the centre, which goes into a slot on the shaft. Line them up, place the impeller in like this, and gradually push it home. Now we're going to put the gasket on. What I normally use is Vaseline, but you could use grease. Smear a little around the outside like so, just to hold the gasket in place. Line up the gasket. Now we're going to put the faceplate back on. It's best to screw all the screws in loosely first and then tighten up in a radial pattern. Back in, and we can now think about trying to restart the engine. First thing we must do is open the seacock. That is something we mustn't forget. Secondly, we need to check the fresh water level. If the engine has overheated, it may have lost some of its freshwater cooling. Finally, before I start the engine, I'm going to put some washing up liquid into the strainer. This will help me identify whether water is coming out of the exhaust. We're going to have a quick look at electronic diesels. These are going to become more and more commonplace as engine manufacturers strive to meet the emissions regulations set down by the EU. The one that we're going to look at is the EDC system from Volvo. Now, this has been superseded by the new D series. However, there's still an awful lot of these engines out in the marketplace. So how does the EDC system differ from conventional engines? It's quite simple, really. If you think of it as two different electrical systems, one is a standard system which has the gauges and alarm system, same as ordinary diesel engines. The second system is an electronic system. There are sensors placed around the engine. These pick up things like the barometric pressure, coolant temperature, engine speed, and they feed this information into a computer. The computer then decides how much fuel and when to inject it into the engine. This is great because it gives us better fuel economy and also it gives us very few emissions. In addition to the gauges and alarms, there is an EDC control panel. If a fault occurs whilst out at sea, say overheating, then like conventional diesels, the gauge will rise and the alarm will come on. If the temperature rises too high, then the computer will cut in and reduce the engine revs. And then we will get an indication on the EDC panel. If, however, the engine shuts itself down or refuses to start, then we need to check the EDC system for faults. If a fault is present, the yellow diagnosis light will then start to flash. And what we need to do now is to retrieve the code. To retrieve the code, we turn the ignition switch to position 1. Then we press the diagnostic button. We now count the flashes. 1-1 would indicate that there is no fault in the computer. If, however, we had a code such as 2-3, so that's 2 flashes, short space, and then 3 flashes, then we would have to refer to the handbook to find out what the fault is. So in order to restart the engine, we need to obviously rectify the fault. We then would need to reset the codes in the EDC system. We have found with some faults that simply going through the reset procedure and resetting the codes is enough for you to get your engine started and get you back into port. So what we're going to do now is to just go through the reset procedure and something that you should know if you own one of these types of engines. So to reset the codes, we put our finger on the diagnostic button and hold it down. We spring the key to the stop position and then straight through to position 1 and count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Move the finger off the button and turn the key to the off position. We now want to check to make sure that the codes have been reset. So we turn the ignition to on and press the diagnostic button. And what we should get now is simply the code 11. That tells us that there are no faults in the computer. And in theory, the engine should start. Now, if it doesn't start, okay, and the fault codes come up again, then we know that the problem is more serious. Previous in the DVD, I showed you how to change an impeller on a yacht. We're presently on a boat with a stern drive with a much bigger engine. So I just want to run through the things to look out for and how we change this impeller. The water on this is sucked up through the drive leg, through the transom shield, down along the bottom of the engine, okay, up and comes up here into the impeller pump. From the impeller it is discharged through the strainer and then out and back into the engine. Right. So if we're happy that the water level is below the impeller, then we can just take the faceplate off. But some of the other engines, the impeller is actually below the water level, so you have to be very careful when you take the plate off. If you're not sure about where the water level is, obviously leave 2 screws in. Just loosen off the screws, and when you break it off, just make sure that the water doesn't come guzzling out. Alright, and if you obviously get a little bit of water out, but if it starts flooding out, then you can do up the 2 screws and then put it back on. Okay, so that's our impeller, and this particular one has a rubber O-ring as a seal rather than a paper gasket. Okay, so in order to get this impeller out, we're going to use an impeller puller. Okay, and they come in 3 different sizes. The one we're going to use is medium size. So let's just get that. So this is a medium size impeller puller. So what we do is these 2 jaws here will grip on the outside of the center shaft of the impeller. So we put that down the side, and then we do up the knurled nut like so until it's tight, until it grips the impeller. And then we wind the center spigot. So even if the impeller looks okay, always have a good check round at the roots and make sure there's no cracks or what have you. This one looks in pretty good condition, so we're just going to put this one back in, I think. If you haven't got an impeller puller, you can use screwdrivers, but you have to be very, very careful. And what I recommend is that you put tape around them so you don't damage this face. So you can put one on either side and lever it out, but put insulation tape around it to protect the face, because what we don't want to do is damage this. Obviously the bigger the impeller, the harder it is normally to put in. If you do have a really big impeller and you want to put it in, one of the things you can do is put a cable tie around the blades in order to help you push it in. So you squash the blades in order for you to manipulate it so you can get it on the shaft. Okay, make sure the seal's all in place. And we'll put the screws back. Okay, so if the impeller had failed and we'd opened that up and found, you know, all the blades were missing, we would obviously had to retrieve the blades. Now some of the blades will have gone into the strainer, so we'll catch most of those, but a lot of them will go back down this tube. And in order to get them out, what you need to do is disconnect this pipe, take the pipe off, drop it down below the water line with your hand over it, and then all the rest of the blades will come out and flood out, and you'll see that it's clear. The next thing I want to go through is the strainer. This is critical on this type of boat. Unlike the yacht, the water was sucked through the strainer, so we had to make sure that it's sealed, otherwise we wouldn't get water through. On this, the opposite applies, because when the pump's running, this is under pressure. So it's important that we reseal it. So we're going to check it, take the lid off, remove the plate, remembering that the nipple sticks out to the top. Then remove the cage, like so. All right, and what we would do is clean this off and unblock it. All right, now putting it back, we must locate it. There's two grooves down the side that this slides into, so we push that down there. Make sure the seal is all in place. It's all down nice and even. Plate on top, nipple up, and then do it up. And quite tight. Now what is really important with this particular type of engine is that you now go up and start the engine and run it in order to make sure this is not leaking. Because if it leaks, then it will leak all over the belts, all over the alternator. The belts will start to slip and they will fail. Not only that, it will cause an enormous amount of corrosion on the front of the engine and will become very costly later. So every time you check this, run the engine, check it before you put the engine hatch down. Okay, one thing to check regularly, which is very, very important, is the belts. This engine comes with 1, 2, 3, 4 belts. Okay, and if any one of those fails, then it can cause the others to slip off. So starting from the outside, we've got the supercharger belt, which is a flat belt. All right, let's just check the tension of that. That's okay. You should be able to just turn it just through 90 degrees, but it should be quite tight. All right. Then we've got the power steering belt on this one. All right, that's nice and tight. Then the alternator belt. This one goes out to the alternator, and that's quite tight as well. The most important belt is the main belt right at the back, the flat belt. Okay, we must check that and make sure that it's not getting slack or it's not wearing through. If that one fails, then obviously the alternator won't work, the freshwater pump won't work, and neither will the supercharger. All right, so if that goes, then the indication will be probably the alternator light will come on the dashboard, followed by shortly by overheating quite badly. So make sure you check these regularly, it's very important, and also carry a full set of spares. It's not an easy thing to change. In order to change the main belt, you have to take the pulley wheel off and take all the other belts off as well. It's quite a long and involved job. It's very important after we've done anything to the engine that we start the engine and give it a good check over, especially make sure that things like the strainer and that's not leaking.